Charles Nutter and I have known each other for many years. The JRuby team used to be sponsored by First Sun. That's where JRuby sort of was given its ability to actually come to life, because it's a non-trivial project. The idea of implementing Ruby, I mean, you say, I'm going to write a language. That's sort of hard, because you've got to think of the language and what works, sort of game design and that sort of thing, and then implement it. So in a way, re-implementing a language should be easier, because Mats did all the hard work. That's what you might think. JRuby has been in development for 10 years. So apparently it's not easy. And so first it went to the Sun, sponsored for a very long time. Then they came to Engineer, they're sponsoring, and now Red Hat is sponsoring, and JRuby. And I say who sponsors these things because I do not believe this is the sort of project that can exist in the hands of, just without corporate sponsorship, without people being allowed to work on it full time. And so I do want to, just in case Charlie isn't very good at saying necessarily dragging attention to those sponsors, I want to do it on those sponsors' behalf. So Charlie and I got to work together for a long time, where on a sort of weekly, fortnightly basis, I would say, Charlie, here's what I think you should do in order to make JRuby really successful. And then Charlie would go and fix something else. And so I want to take a moment for anyone that's wondering about how we can make JRuby successful. And I'll tell you. And then perhaps you'll do it, since I still can't get Charlie to do it. All right. What we need to do is, it's all about the distribution. You've got to get it to people and make it as easy. So that's part one. And part two is all the basic use cases that people have, which perhaps you could summarize down into Rails. If you can't if you can't go Rails new and get a working app that runs on JRuby, and you can't run it in all the places people want, they're just not going to. And so an example of what used to, it's really wrong to talk about someone else's talk, but he's not going to talk about these things. And I care greatly about the success of these projects. So, and you probably just think I don't know anything. So the other thing you need to do is to constantly make things work. People want to use Twitter Bootstrap. For the longest time, Twitter Bootstrap didn't work on JRuby. People just wouldn't use it. And so if you care about the success of JRuby, and I think after the next 30 minutes you will, and MRI and the others. But after this 30 minutes in JRuby, and you're wondering how can I help, you can help by making it work everywhere. So please put your hands together for one of the creators and looker-afterers of JRuby, Charles Nutter.
Nice to see you, Nick. Thank you. Thank you. All right. Looks like we're ready to go, and we got about 85 slides to do in 30 minutes, so we're going to go for it here. Talking about the future of JRuby, obviously. Let's get into the basics here. That's me. I've been doing Java stuff for a long time. JRuby, I'm amazed and honored that I've been able to work on it for full time for 7 years now, and we must be doing something right that people want to keep paying us. Currently at Red Hat, part of the JBoss Polyglot group, but pretty much just hired to work on JRuby. So again, another of these companies that's willing to fund a project that isn't really like a bottom line money maker, but it's an important one for the community. So how many people have heard of JRuby before today? That's good. I would hope that it'd be almost everybody in the room. How many people have actually tried using JRuby for something? Okay, that's still like 3/4 of the room or so. And how many people are using JRuby for something right now? In production, some application? All right, good. So it's probably about 1/4 of the room. Hopefully, we'll have more of you interested in doing that after this talk. So let's do the basics first. What is JRuby? Obviously, it's Ruby on the JVM, which, what does that mean to people? Usually, it doesn't mean good things to people when they first think about it. The first thing is that, oh, well, I don't use JRuby because I don't like Java. And that really doesn't make any sense at all, because it's not a Java implementation. It's Ruby. It's a Ruby implementation. There's all sorts of legacy from the past of Java that just continues to dog us forever. People think that JVM is slow and that applets suck and Swing sucks and all these applications are crap and everything is going to be these massive names. And this is the only way that you're going to be able to build an application with JRuby is if you do it in the Java way all the time. And of course, this is nonsense. And hopefully anybody here that has ever dealt with Americans will know that stereotypes are kind of annoying sometimes. So let's talk about what we have here in Spain. Obviously, the Spanish Inquisition never ended. It's just continuing on, and it's hilarious, too. You're all bullfighters, and that's all you ever do here. Of course, everyone takes a nap sometime during the day and spends most of their workday sleeping. And then, of course, for Americans, it's even better. You're all also mariachis, and you have tacos, and you're all lucha libre, you know? So obviously, stereotypes are very tough to shake, especially when it's people who really don't understand what you or your project or your beliefs or your work is about. So let's leave all that at the door. JRuby is Ruby. It's a Ruby implementation that just happens to be implemented on top of the JVM, happens to use Java instead of C for a lot of the parts of the internals, but it is a Ruby implementation, and that's what we need to emphasize when we talk about JRuby. So the basics of JRuby, the current releases are compatible with Ruby 1.8.7 and Ruby 1.9. By default, it runs in 1.9 mode. It's mostly written in Java internally, similar to how MRI is mostly written in C, but it's pretty clean code. We've got some pretty strict coding standards. We've done a lot of work to refactor and clean the system up. And we are trying to do more and more of JRuby in Ruby going forward. A lot of the newer 2.0 features are at least half written in Ruby, a bunch of 1.9 stuff as well. And the really interesting part about running with JRuby is that you have the entire JVM available to you. Libraries written in Java, written in Scala, written in any other language that runs on top of the JVM, you can access as though it was just a Ruby library. And that's pretty powerful. Here's where we are in our release roadmap. We did the 1.6 releases last year, and they were well received. Every time we do a release, we tell everybody, no, this is the one. All those other releases were crap, but now this is the one that's really going to be awesome for you. And so then we went to 1.7, and this is the one. It has been faster than 1.6. 1.9 compatibility has been better and continues to get better. And we are really hoping we're going to get the 1.7.5 release out in the next week or two. It's kind of dragged on trying to finish up 1.9 features. Beyond the 1.7 series, we ran into a little problem. We didn't want to name the next version of JRuby 1.8 because of the confusions with Ruby 1.8. We didn't want to go to 2.0 because of the confusions with 2.0 of MRI. So we're just going to say, screw it, it's just going to be JRuby 9000. So the next version of JRuby will be JRuby 9000. The plan is to actually branch off and start doing this work after 1.7.5, which is another reason we're really interested in getting it out the door. And then, of course, once we do the first point release after JRuby 9000, we'll have JRuby over 9000. So now with JRuby 9000, the main changes we have, it's going to be probably Ruby 2.0 or 2.1 compatible only. 1.8 support is gone. 1.9 support is very likely to be gone. Possibly will be Java 7 only. Java 7's been out for almost 2 years now. It's possible that we may move up so we can take advantage of more features. And there will be a new compiler and runtime for better performance. It's not quite clear what that is yet. All right, so talk a little bit about why you want JRuby. For the folks that hadn't tried it yet or aren't running it in production, why do we think that JRuby's an important project for you to use? Well, the first thing is the actual way the team is laid out. And now, of course, a lot of people think this is the JRuby team, and I'm the only one that does any work on it, and that's absolutely not true. There are two of us that are co-leads of the project. There's me and there's Tom. Then there's a number of other developers, contributors that come and go, dozens of people that we've had over the years working on JRuby. But even this isn't the entire story, because there are whole teams of people underneath that are working on all the different JVMs, OpenJDK and Hotspot, Android, the Dalvik VM, the J9 VM from IBM, HP has one. There's a whole bunch of other JVMs out there by hobbyists. Lots of different people that are doing this work. And as a result of all the work that continues to go on in all of these JVMs, and especially Hotspot, here's an example of what would have happened at JRuby 1.0 if we just stopped working on it completely. And it actually means, what this graph is telling you is that over time, if we had just let the JVM improvements drive JRuby's performance forward, we would have been 300% faster without doing any work at all. And the funny thing is that we actually would have eventually been faster than CRuby 1.8 without doing any additional work. Obviously, we've done a ton of work, and we've continued to improve over time, but this is the benefit of being on top of the JVM, continuous progress forward on performance, garbage collection, and everything else. And speaking of garbage collection, this is another piece that we get for free. Anybody else that does a Ruby implementation that's not on top of an existing VM has to build their own garbage collector. And this is a black art to do this really well and to get it to scale. This is Ruby 2.0, the amount of time each garbage collection event takes, depending on how big the heap size is. And as the heap size increases, the garbage collection time takes more and more. Whereas with JRuby, because of the way the JVM's garbage collector is built, because of the generational garbage collector, which hopefully will help Ruby 2.1 as well, garbage collection times stay mostly consistent. By not having to worry about all of that other JVM stuff, we've managed to be able to concentrate on Ruby features. This is a pseudo-graph, pseudo-true numbers here of JRuby chasing MRI as far as features go. There was a big bump up for 1.9, a little bit of a bump for 2.0. We're hoping that by Ruby 2.1 we're going to be caught up, and we're just going to stay caught up at that point. Now, however, JVM development doesn't go very fast. From 1.4 to 1.7 was at least a decade of work that happened there. So we can't just wait for the JVM to move us forward. We need to constantly be improving. And that's what I'm going to talk about today here. Spend the next 20 or so minutes talking about what we're doing to make JRuby better in the future, regardless of what happens at the JVM level. Talk about performance first. So Ruby is hard to optimize. Lots of dynamic calls that have a lot of overhead, lots of objects that are being created, and the objects themselves potentially change shape at runtime. It makes it very difficult to optimize any of these pieces. So what are some things that we're doing today? Well, right now, we compile everything to bytecode on a lazy basis. If a method gets called enough, it turns into JVM bytecode, and obviously that's what the JVM wants to do, wants to see as far as optimization goes. But can we do better than this, not just dump it down into Java bytecode? And a few years back, we started working with JVM engineers about adding a new feature, a new function, a new bytecode to the JVM called Invoke Dynamic. Invoke Dynamic basically gives us a way to teach the JVM exactly how Ruby method calls are supposed to work and exactly how Ruby objects are laid out, even if it's not a standard Java thing, but it will optimize like Java once we've done the work to teach the JVM. And let's see how this actually works for us. Here's a graph of RB tree library, the pure Ruby version versus the native version across several implementations of Ruby. So we have the pure Ruby version on Ruby 1.9 and 2.0, and don't let anybody tell you that MRI is not moving forward on performance. They definitely are doing great work as far as optimizing with what they have and around the restrictions of C extensions, garbage collection, and whatnot. Ruby 2.0 on a lot of benchmarks I run is anywhere from 1.5 to 2 times faster than Ruby 1.9. And with the new garbage collector, that could improve even more. So they are moving forward. Two other Ruby implementations that do some compiling and jitting, maglev based on the Gemstone Smalltalk VM, and MacRuby, which has a sort of an ahead-of-time JIT, compiles it down to the Objective-C runtime. And again, these are better. Now we're actually getting down to native code, and performance is improving. Rubinius also has a JIT and compiles Ruby code down to native, and they're starting to show performance that can sort of compete with the C extension running on Ruby 1.9 or 2.0. And then, of course, there's the JRuby numbers. So this is JRuby running the Ruby version of RB tree compared to, say, Ruby 2.0 running the C extension. And it's actually faster to run the Ruby version on JRuby than the C extension on MRI. This is the real promise of the JVM and Invoke Dynamic. And it's been a great experience to have this performance come along, but there's been some caveats along the way. Again, we can't always count on the JVM to be just as perfect as we want it. It was slow to begin with. Once they sped it up, there were a bunch of bugs that had to be fixed, actually caused them to have to rewrite a whole bunch of the Invoke Dynamic stuff. It's slower to warm up than just running with the old code. By the time Java 8 comes out, maybe we'll have this final good version of Invoke Dynamic, but it's been very frustrating for us. So what else can we do? What else are we looking at? Other options that we have, in JRuby 9000, we're going to be replacing our simple AST-based compiler with a new IR compiler. be able to apply more standard compiler optimization techniques against this IR structure rather than against an AST. We can optimize the Ruby code before it goes to the JVM. We can specialize types. If we see it's always fixed num logic, we can make it raw native integer operations. So it looks something like this. What we have today, we do our lexical analysis parsing, turn it into an AST, and then just walk that AST. Eventually, that AST gets turned into bytecode in a fairly naive way. What we can do with the IR is actually do some additional semantic analysis, type analysis, optimizations, turn that AST into a more optimized control flow graph, and then do bytecode generation for any number of backends just based on that optimized version of the Ruby code. Here's a quick example of what the IR actually looks like conceptually. On the left is the naive version that we get out of this simple piece of Ruby code. And on the right, we've done some optimization passes, eliminated some dead code, propagated that one value through to the C variable. And you can see we start to boil it down to what the actual essential work of the code is. Another option that's come up recently, Oracle recently announced a project called Grawl. Grawl is essentially a direct API to a native JIT. It's a sort of a specialized version of OpenJDK, specialized version of Hotspot, that allows you to emit the optimized internal representation rather than going to JVM bytecode. So that opens up possibilities. A project they worked on for the past year called Truffle uses Grawl to optimize a simple AST and turn it into much faster code than you would get generating JVM bytecode. It does a better job of mapping the language all the way down to native code than trying to pass it through this intermediate layer. So Ruby on Truffle, they've done a prototype implementation to kind of show this off. And right now it's like 5 to 6 times faster than JRuby. But there's a lot more work that has to be done on Ruby Truffle to actually get to the point of being usable. Truffle and Grawl themselves are still research projects, and the functionality-wise, it can't run much of anything. They showed 2 benchmarks, because that's about all they could actually run. So where does that leave us with all these different things? Well, we're going to keep working with the JVM guys to improve Invoke Dynamic. We're going to get our own optimizing compiler done and do the optimization work that's similar to Truffle and Grawl. Probably explore those other JVM backends to see if we can maybe get the same sort of performance gains just using JRuby and keeping all of our compatibility. And if you're interested in compilers or optimization work, we'd love to have folks on the project. All right, so concurrency-wise. Concurrency is something that's been coming up a lot at Ruby conferences, including this one. Hopefully everybody knows this general pattern. Ruby 1.8 with its green threading really only had one native thread that it passed thread contexts around to. So only one of those was ever executing at a time. Ruby 1.9 and 2.0 do have multiple native threads, one per Ruby thread, but it only allows one to execute it at a given time, mostly because the internals of Ruby itself are very difficult to make thread-safe, to make consistent with many concurrent executions. JRuby, however, we have done that work. The JVM itself has done that work, and running with multiple threads in JRuby actually will use all the cores in the system. So you look at what multi-core processes, multi-concurrency processes, applications in MRI look like. If you want to be able to do things concurrently on MRI, this is your only pattern. You need 10-way concurrency, and you need to be able to do 10 things at once. You need 10 processes. And when we're talking about a web application, that can be 100 meg, 200 meg, 300 meg for each one, just to be able to do concurrent requests. And now if you need to scale even more, you're trying to become the next Twitter or the next Facebook, well, it becomes absurd at this point, because all of these different concurrent requests are going to demand another instance of Ruby every single time, and you're going to be paying more for the hosting and the memory that goes into this process than you're going to be getting out of it. And now, of course, it's totally different in JRuby. We do use a little bit more memory as a base, partially because of garbage collection, partially because of some of our internal structures. But that single instance can handle the 10 threads. That single instance can handle the 100 threads. And we actually have people that will spin up a single JRuby instance and crank tens of thousands of concurrent requests through like a 200, 300 meg process. That's better utilization of the hardware. That's better utilization of the resources available. Now, there's also caveats here. This is really awesome stuff, but concurrency is hard. Threading is hard. The Ruby world has not quite grown up into concurrency yet, mostly because options like JRuby are still fairly new. So we need to do more to help this process along. Let's look at a few of the unsafe things that you will run into when you start doing concurrent programming in Ruby. Read and write operations done concurrently on strings, arrays, hashes. On JRuby, Rubinius, any of the actual concurrent implementations, there's a very good chance that the data itself might get corrupted, or in some cases you might actually get exceptions, get crashes along the way. We've made the decision that those things are not going to be thread safe, mostly because the overhead involved would kill performance for all users, regardless of whether you're doing concurrent stuff or not. So we need a better way to deal with that. Most folks don't realize that operations like plus equals and or equals in Ruby are not done atomically. They essentially expand out to equals, x equals x plus 1, or cache equals cache or the new cache. And anywhere along that way, even in regular C Ruby, another thread could jump in and change the result. If this myCache object is very expensive, or you really, really only want to create one of these, there's a very good chance that you're not going to be safe in this situation. Another thread might create an additional one. And incrementing, of course, you're going to have other threads bumping it all over the place. And then thread pooling, coordinating threads, basically being able to spin up a lot of concurrent processing and manage it. Very difficult stuff to do. Let's look at a few options that we've got for this. The first one's a gem I released called ThreadSafe. Other folks have added to it and improved on it over time. But this provides you a concurrency-safe hash and array. ThreadSafe array new, ThreadSafe hash new, and you've got concurrency-safe objects that look and feel and act like the regular Ruby versions. Very easy to pull this gem in, start using these. Performance should be just as good as a regular one, maybe slightly degraded for concurrency guarantees, but it's going to be safe and you can use it across threads. If you are interested in the persistent data collections, for example, what Paulo was talking about, immutability is a beautiful way to get safe concurrency, and there is an excellent library available for Ruby called Hamster. It's a pure Ruby implementation of a whole bunch of different persistent data structures. There's hashes, lists, sets, and so on. This quick example shows a hash where we create it, we can query it like a normal hash, but we're always guaranteed that it's thread safe because any mutating operation, any change to it, creates a new hash for us, a new reference. So no one's ever going to be able to mutate a given hash object out from under us, or a given persistent vector, persistent array object out from under us. Very simple, very clean way to get concurrency, especially if you're mostly write or you're mostly read-driven and might have a few writes coming in and changing stuff. If you want to be able to do those updates atomically, plus equals, or equals, and so on, we need some sort of atomic operation. We've talked about trying to get this into Ruby proper, but in the short term, there's an atomic gem that essentially is your atomic update. Here's a quick example of this. We create a new atomic object, which is sort of like a single element array. It has one object reference inside of it. You can query that value. You can swap it for a different value. You can swap it only if it hasn't changed to make sure that you're not doing an update that has been stepped on by somebody else, not stepping on someone else's work. And then the lower part of this, actually telling the atomic object, do this update only if someone else doesn't jump in at the same time, thread-wise. If it's successful, it'll allow you to put that change in, that change will be committed to the object, and you won't ever step on any other threads. And you can do your safe incrementing, your safe or equals logic with the atomic object very easily. And it should perform at least as well as you would expect with the regular Ruby code. The last one I've just been playing with recently. Any Go fans here? There's a few. It's growing in popularity. Go has two concepts that would be very nice to have as standard things in Ruby. One is called Go routines. It's very much like fibers, lightweight threads that you spin up and they run concurrently, which is different from fibers in Ruby, and channels, where you put some data on one end, it comes out the other end into a thread somewhere, but you're guaranteed that it's always going to be a safe operation to coordinate all these different threads together. Here's an example of the Go pinger, ponger, printer example from the Go documentation. So we've got 3 different Joe routines, coroutines here, that are going to be running. One of them is going to be pushing pings into this channel, one of them is going to be pushing pongs into the channel, and then a third is going to be printing whatever comes off of that channel. And this code is nearly identical to the Go version, just using a little bit of Ruby metaprogramming magic and some of the JVM concurrency primitives under the covers. So another library easy to play with. And of course, there are lots of these libraries. This is just a few that I've worked on. There's other people that have done actor frameworks, such as Celluloid. Hopefully you've all had a chance to play with Celluloid or use it or at least hear about it at one of these events. Concurrency can work in Ruby if we're using the right tools and the right patterns for it, and learning from other platforms that do concurrency well, like the JVM, like Clojure. Immutability obviously helps a lot. And probably the bottom line here is that if you are going to start doing concurrency and you want to make sure you're doing it right, don't test it on MRI, please, because that doesn't even make sense. You have to test it on JRuby or potentially Rubinius to really get the concurrency. And test it on as many cores as you can. Spin up some extra large on Amazon and see what sort of crazy stuff comes out of it. All right, moving on to native extensions here. The fun one. So why aren't these things written in Ruby in the first place? There's really 2 reasons. There's performance. Sometimes it's fine-grained. You need a lot of little down calls into C. You're implementing a Ruby object with C code. Sometimes it's coarse-grained, like an RMagic sort of thing. You're tossing work over the fence and getting something big back. Or it's just general library access. You're using the MongoDB client or the 0MQ client. So we did support C extensions in JRuby 1.6. It was sort of limited. It's been disabled now, mostly because it kind of worked, but nobody really wanted to maintain it, and there were a lot of problems, a lot of limitations. Probably the biggest one was performance-wise. In order to emulate the Ruby C API and the way and support the way that people use it, we had to do a lot of copying back and forth. We had to be locking around the C calls to make sure that the C code didn't blow up. It was impossible to do multiple JRuby instances in one JVM because the C extensions didn't know which one they were associated with. And it's really just a massive API to try and support. We didn't have the cycles to try and do all that, and it turned out that most folks weren't actually interested in C extensions on JRuby enough to do this sort of work. So alternatives here, solutions to this. The first one we always recommend is just use JRuby's Java integration. Find a Java library that does what you need and call it from Ruby code. It works very nicely, it feels like a Ruby library, and most of the time, this will get you the same functionality that you need. You can potentially even wrap it with a compatible API. Here's an example of creating a JFrame, a JLabel, using the Swing API from Ruby code. And we've done all sorts of work to make this look nice, like default close operation equals is the set default close operation function in Java. This is probably the quickest and easiest way to get some additional functionality that you don't have in Ruby. You can write the equivalent of a C extension, a Java extension for JRuby, wrap some library, get it as fast as possible. Maybe the second thing that we would recommend to people if you want to be able to use an external library. But unfortunately, sometimes you actually do need to go down to the native level. And that's where things like FFI come in. FFI is basically an API or DSL for calling native code from Ruby. Very easy to bind in a C library and do some calls to it, and it kind of solves that access case at the very least. If you're doing, and performance-wise, if you're tossing a whole bunch of work over the fence, it's also very good. Here's a quick Ruby FFI example. We've got a time val struct that we're going to pass into the getTimeOfDay function, just a standard POSIX function for getting the current time of day. And now this is all pretty clean and easy to code to follow, and you can do some pretty extensive FFI bindings, but there's some caveats here too. Structures can be a real pain to bind across platforms, across compilers. They're going to lay out differently. You're going to have to do a little experimentation to figure out what the actual layout of the structure is. And then fine-grained performance kind of hurts. So replacing C extensions with this doesn't really get us all the way. For the struct access, there is a project called ffigen, which allows you to generate all of the structures using the same compiler libraries that LLVM's Clang does. Under the covers, it generates the metadata for all of the headers, all the structures, and then creates Ruby code that binds it all into FFI. And this is really the only code that you'd have to write in ffigen to do this. You give it a pointer to a header file somewhere, you give it a pointer to a Ruby file you want it to spit out, and it creates FFI code for you. Pretty amazing that it can do this. If we could get it to do this basically at boot time, or at install time when you install a gem, it would be almost as good as a C extension, because it wouldn't have to worry about structures, and it would have compile metadata. You get some code out of it like this, and I believe it actually pulls in comments from the C code. I'm amazed by that, but it's pretty impressive that it generates rdoc based on the C code comments. And then there's actual binding to a function that it's generated. The last thing for C extensions that we're trying to work on is basically a new way of doing C extensions. Wayne Meissner, the guy who did our FFI work, has come up with a project called XNI. Now, XNI allows you to basically just write normal C code, and that becomes your Ruby C extension. It'll compile when it installs and bind using FFI, so you get both the C compile side, generating structures properly, working with the objects correctly, and the cheap binding without the invasive MRI-C API. The quick example here, this is one function from the high time C extension. And you can see there's a lot of little Ruby nuggets in here. The things are passed around as values. You have to data get struct the high times interval out of it, and then work with it. You have to know about Q true and Q false to return these things as appropriate Ruby values. Here's the XNI version. The XNI version just takes in a normal high times interval structure. It works with it directly, returns true and false as you would in normal C code. And then it uses the FFI magic behind the scenes to bind this. Rather than having to write to Ruby's internal API, you write C, and you bind it with FFI. All right, the last one I got here, and this should work out just perfectly. Startup time. This is by far the #1 pain point that people run into with JRuby, and we feel the pain too, because we have to run JRuby every day for testing purposes. It is a hard problem to solve. When CRuby boots up, 95% of the code that's executed is all native compiled C code. The parser, the interpreter, all the core classes. That's why it's able to start up so fast. It's already compiled down to the fastest possible native stuff. Whereas in JRuby, almost all of that is written in Java, and it takes some time for the JVM to warm up, JIT it, turn it into native code. So that's difficult for us to be able to compete on that level. Even if we write awesome code that's really fast in JRuby, the startup time is always going to be slow. So we have to find another way to get around this. It's aggravated by the fact that a lot of different Ruby styles of development and a lot of different Ruby libraries spin up many child processes. One of the worst here, rake test, spins up like 3 or 4 or 5 sub-processes to do isolated test runs. And every one of those has a full-on JRuby startup time hit. This will be aggravated further if we're going to our IR. We don't want to have to do all of the IR compilation every single time we boot just to get Ruby code going. So we need something to solve this too. The first one that we've played with is something called Nailgun, and now working with some guys that are working on a project called Drip. And what these basically do is keep a JVM in the background, warmed up and ready all the time. So all you do is toss commands to it, and it gets it up and going as fast as possible. There are issues with this, like signals. The I/O channels aren't necessarily the right ones when you try to do standard I/O, TTYs, and whatnot. And it doesn't actually make Rails a whole lot faster, because there's still a lot of requiring logic, a lot of boot time stuff that has to be done for Rails. So we tried to look at doing IR persistence as part of the Google Summer of Code last year, and it kind of worked. We got the basic functionality there for persisting all of the IR stuff, skipping, parsing, AST compilation, and all that. But it turns out that the size is really a problem. We had too much data being dumped out. And more importantly, what we really need to do is be a lot lazier as far as what we load at startup. We don't want to load the entire world. Here's a little table of what code is loaded and defined for a few simple operations in Ruby, and what percentage of it actually gets called. And in almost every case, it's like 80% of the code that's loaded is never touched. If we can avoid loading that code, we can improve startup. And so the big payoff here is that we're going to have a new IR persistence format that we can lazily load methods, lazily parse these files, only load that 10% that you actually need. And then potentially combine that with Nailgun. Have a background VM that's already got everything that you need loaded, shares it across all the JRuby instances, and hopefully that will get us much closer to starting up as fast as MRI. All right, so closing it out here. Ruby is still very strong and continues to grow. And MRI is growing and improving too. Every release, there's more amazing things that are coming into it as far as performance, GC, and whatnot. Don't let anybody tell you that Ruby can't do concurrency. The only problem with concurrency in Ruby is Rubyists right now. We need to learn better ways to do concurrency, learn the right patterns from the worlds that do it well, and improve our own use of concurrency in Ruby libraries and applications. C extensions are holding us back. That's come up multiple times, and we need to find a solution. But don't give up on Ruby. Just because some of these things are hard, work with us on JRuby, work with the Rubinius guys, find ways for us to improve Ruby and make it do what all these other platforms can do. And we'll all be a lot happier because we can continue to use Ruby every day. And that's all I have. Thanks.
So I'm familiar with AST, but I've never heard of IR. Can you tell me a little bit about that?
Okay, so IR, it stands for intermediate representation or internal representation, whereas an AST is basically a tree of representing the syntax of the code mostly. The IR is more trying to represent the semantics of the program. So, am I still on? Okay. So the IR will be like step through the code, the actual operations that's going to be performed, rather than a tree representing we've got an if, and we've got a conditional, and we've got this and that. Allows us to see more the flow of the program and how data actually moves through the application, and as a result, do a better job of optimizing what data you see, how that program flow works, pieces of code we don't actually need to run. It's hard to see that with the AST.
Are you guys working on getting integration with JMX so you can do the monitoring from, create your monitoring functions from on the Ruby side and dtrace and JMX, for runtime monitoring?
Right. So JMX and dtrace. First of all, JMX, we've had support for JMX for a while. Tom Annabo, the other JRuby guy, has a gem called the JMX, I think it's just called JMX Gem, that it provides both the client side, so that you can query and pick up other JMX processes, and the definition side, so you can define JMX endpoints just with regular Ruby code. And that works great. We've used it to instrument controllers and whatnot and show how that works. So that's out there. Dtrace-wise, one of our Google Summer of Code students this year is actually doing work to implement dtrace probes for JRuby using the existing JVM stuff. And he has it working on Solaris. We need to work with the JVM folks to get the OS 10 dtrace support working at the JVM level. But it's there and should be in a future release.
Hi. Is there any significant difference between writing, C extensions for MRI and Java extensions for JRuby?
Any significant differences? Well, one's written in Java and one's written in C.
No, I mean...
So that's one. Outside of that, it's mostly the differences of Java versus C. You're not doing a lot of your own memory management in writing the JRuby extensions. There was a bullet in there that said it's all just the same objects. You create Java objects or Ruby objects. It's all in the same heap. It's all GC'd and managed the same way. So that's a big benefit. Beyond that, we've done a great deal of work to make the Java extension side optimize extremely well. For example, if you have a method that takes 1 or 2 or 3 arguments, you can define 1 or 2 or 3 Java methods, and we'll dispatch straight through to the right one, much faster than you can do in C, because it's going to have to do all the argument processing. And we're doing more and more of that all the time. But calling from Ruby into a Java extension is practically free. It's really fast. And with Invoke Dynamic, it optimizes as if it was a Java to Java call.
So with the new copy and write garbage collection improvements that are coming in Ruby 2.1, do you think that the process per request model will be able to catch up to the thread per request model? Or
all right. So
in terms of memory consumption?
Right. So copy on write, as far as mitigating the memory issues of process concurrency. Ideally, it would. What I've heard from most people that have run with Ruby Enterprise Edition or other copy on write setups, even with the Ruby 2.0, 2.1 stuff, is that if it runs long enough, those processes eventually do kind of grow up to the same size anyway. I have not heard anybody that said, this absolutely reduced our memory down to like 1 instance worth of memory usage, just because there's so much stuff that happens after you boot, after you get those applications up and going. The memory in Rails itself, the memory that your application is using can't be shared across all those instances. So I think it helps a bit, but from what I've heard from most people, it doesn't solve the problem. So it may be that you've got a 200 meg process and a bunch of 100 meg processes, but you're still not scaling the way you should.
Okay, thanks.
Looks like the last one.
I think there might be another one up the top.
Are there any advantages to running, the different JDKs, or is it all, same ballpark really? I mean, are there any advantages to running the Oracle JDK over, Open JDK?
Right. Well, so we primarily test against Oracle JDK, which, contrary to popular belief, basically is just Open JDK. It is the actual GPL, the open source JVM that's out there. Mostly because that's the one most people are going to run with. So that's what we test against. But there are other JVMs that have advantages. There are small JVMs that would be better for JRuby in embedded situations, like the Cacao VM works pretty well. There are VMs that are optimized or set up specifically for different platforms, like J9 works on IBM systems better than the Oracle ones do. And then there's folks like Azul, who has a JVM of their own called Zing, with the only true concurrent garbage collector. You can run this thing with a 128 terabyte heap, and never see a garbage collector pause for the entire application. Now this gets into the realm of commercial JVMs where you have to pay for that kind of functionality. But there's a wide variety of different VMs that JRuby, as long as this is a Java compatible JVM, should run great on top of.
Thank you. Thank you.
All right.
Got one at the top.
So you seem to be pitching.
Zell down.
You seem to be pitching JRuby to web developers since you've been mentioning Rails a lot, right? So I'm a web developer, and obviously I don't think I would use JRuby in development because I don't have the same, concurrency problems in development. Most of them don't, and memory problems as well. So we would probably want to use it in production, right? And you've been mentioning, I'm not familiar with the red-black tree benchmark that you've been mentioning, but does this benchmark faithfully represent the kind of data crunching that web applications usually do? And what sorts of other benchmarks would you have to offer to convince me to try to switch in production to JRuby?
Okay. So I will address the first part. We do have people that run JRuby in development, and that's probably the big reason they're trying to continue to work on startup time. However, a lot of shops nowadays are actually able to run MRI as their local development environment and then put it into production and have test and production run on JRuby because the library parity is starting to get there. As far as benchmarks and representative numbers, red-black obviously isn't typically what you're going to be doing unless you're doing a red-black tree startup company. But what these do is they provide the baseline for us to understand what Ruby performance is in general. As we find things in Rails that don't match the existing benchmarks, we'll add more benchmarks. And there are folks like the Torquebox team. Torquebox is a Ruby wrapper around all of the JBoss services. So it's just a single server with queues and in-memory caching and all that stuff. The Torquebox guys have done several benchmarks of Torquebox running, for example, Redmine, and just checking out latency, requests per second, memory utilization, and all that. So there are other benchmarks that are out there that show that JRuby can scale significantly better than any of the CRuby versions. So we're definitely looking for people that have apps that don't scale, because if there is this, it usually means something's broken and we can fix it. Is that it?
Please put your hands together for Charles Nutter.
Thank you.